Welcome to This Explainer. If you're studying computer science or actively building modern web apps, you know how crucial data retrieval is. Today, we're going to completely unpack the internal mechanics of two absolute heavyweights in web architecture, the dynamic RAG system and the hierarchical page index. Let's dive right in. Here's our roadmap for today. We'll start with a big picture look at these two core architectures, then literally trace the data flowing through a RAG pipeline. After that, we'll map out a classic page index tree structure, stack them up for some key architectural differences, and finally look at how you'd actually deploy these in real-world web development.
Section 1, two core web architectures. Let's set the stage.
Picture a massive map of modern web information systems. It's essentially a tale of two cities. One approach is the dynamic, AI-driven RAG pipeline. It's all complex mathematical conversions and real-time semantic searches. The other approach is the page index, which is that highly structured, tree-based hierarchy that has quite literally been the backbone of web navigation for decades. They look totally alien to each other, right? But that's because they are engineered to solve fundamentally different problems.
Let's zoom in on the first one, Section 2, inside the RAG pipeline.
Okay, so what does RAG actually do? It stands for Retrieval Augmented Generation. We all know large language models can be, well, unpredictable. Sometimes they hallucinate facts. RAG exists entirely to fix that. Its job is to ground those LLMs with hard, factual, external data. It essentially forces the AI to look up the facts before it speaks, ensuring you get accurate, context-aware answers.
Let's trace the data through the ingestion phase, step by step. Step 1, we gather raw data. Think PDFs, internal wikis, or databases. Now, you can't just dump a gigabyte of text into an AI prompt, right? So step 2, we chunk it. We split that massive document into smaller, bite-sized context pieces. Step 3 is the magic trick, embedding, where we convert those text chunks into numerical vectors. And step 4, we store all those shiny new vectors into a specialized vector database for lightning-fast retrieval.
I want to pause on this idea of embedding for a second, because this is the absolute mathematical engine of RAG. We're moving way beyond simple keyword matching here. Think of it like taking a chunk of text and plotting it as coordinates in a massive, multi-dimensional space. Because of how the math works, concepts that mean similar things end up mapped super close to each other physically in that space. It's brilliant, and it's what lets the system instantly find relevant info, even if the exact words don't match. So how does it answer a question? Welcome to the query phase. Step 5, a user asks a question, and boom, that question instantly gets converted into its own vector. Step 6, the system searches the vector database to find the top K chunks, basically the closest neighbors in that coordinate space. Step 7, we augment the prompt by smashing those retrieved facts together with the user's original question. Finally, step 8, we hand that whole informed package to the LLM to generate its response. And the output? It's a highly accurate, context-aware, and completely relevant answer. The AI isn't just taking a wild guess. It's practically citing its sources based on verified context. It's a total game changer for AI reliability.
All right, let's shift gears. Section 3, a page index tree structure. Time to look at traditional architecture.
Unlike RAG, with all its vector math and dynamic searches, a page index keeps things grounded. It relies on explicit, static parent-child relationships. Think standard HTML links. It's a highly structured hierarchy designed entirely to organize a website so both human users and search engine crawlers can navigate it without getting hopelessly lost. If we trace the flow here, it's incredibly logical. You always start at the top, the root page, which is usually your home page. From there, you branch down into child pages. These are your major categories like About Us, Products, or a blog. And finally, you branch down to the leaf pages. These are your final destinations holding the actual specific content, like a particular tech article or the details of a specific pair of sneakers. Why do we still heavily use this? Because it works beautifully. It creates an organized, logical content structure. It makes navigation a breeze. It scales up nicely, even for massive enterprise sites. And honestly, mapping out these explicit relationships is absolutely vital for SEO and giving your users a solid, predictable experience.
Okay, let's bring it all together. Section 4, key architectural differences.
If we put these two in a head-to-head table, the contrast is stark. For core tech, RAG relies on dynamic large language models and vector search, whereas a page index depends on a static tree-based structure. Consequently, their main goals completely diverge. RAG's mission is to answer user queries with real-time external data. A page index's mission?
simply to manage and navigate a structured layout of web pages.
But the starkest difference? It's how they handle data. RAG is a beast at taming unstructured data. Loose PDFs, random web scrapes, you name it. You just run it through an embedding model and you're good to go. A page index, on the flip side, demands rigid structure. It needs predefined pages, categories, and explicit links.
Let's make this concrete. Section 5, Real-World Web Development. Imagine you're building a modern e-commerce application. Where do you use what? Well, you deploy your RAG system to power the smart features, maybe an AI chatbot answering specific product questions, or an internal knowledge assistant for your support team. But you would absolutely rely on your page index to generate the site's main navigation menu, to build those little breadcrumb trails at the top of the page, and to structure your XML sitemaps. So the key takeaway here is pretty simple. Pick the right tool for the job. Need dynamic AI answers synthesized from a massive knowledge base? Build a RAG pipeline. Need a structured, reliable map for users to browse your actual website pages? You need a page index. They serve entirely different, yet equally vital functions.
Which leaves us with a pretty fascinating question to consider as we wrap up this explainer. As web architecture keeps evolving at lightning speed, will dynamic RAG retrieval eventually become so good that it makes hierarchical website menus totally obsolete? Or are both systems forever complementary, with AI always needing that structured hierarchical tree to actually ground its understanding of the web? Definitely something to think about the next time you're mapping out a project. Thanks for hanging out and keep exploring these incredible systems.